So as we kick off, I'm just going to give you a little bit of an introduction to who Agritecture is, who is producing and hosting this event today. I'll be introducing myself as well in a brief moment. So let's just talk about Agritecture, which, as you can hear, is agriculture and architecture together. And that's because we really like to practice design thinking, and we really like to solve some of the greatest challenges around agriculture by thinking the way that architects think about choosing all the different ways we can solve these problems. And we've got an incredible team around the world that works on all kinds of projects related to agricultural challenges. So here's a little bit of background about us. Back in 2011, I got really curious about vertical farming and urban agriculture, and I was kind of disappointed by the content that was out there. So what did I do? I started a blog called Agritecture, and I started blogging about different projects around the world, how people were building rooftop farms, greenhouses, vertical farms, all of these new trends. And I would visit farms and talk about them. And that really was exciting because I got to learn a lot along that journey and create a great digital community as well. And we are the most popular blog still to date in controlled environment agriculture, which is greenhouses and vertical farms. And we're so glad, if you're a follower of ours, that you've joined us again here today. In 2014, I started getting consulting requests. People said, I want the data. How much can we grow in a greenhouse, or how much can we grow in a vertical farm? What does it cost? And so we started the first global urban agriculture consulting firm in 2014, and we've really diversified and grown a lot beyond then. And then in 2020, we decided to scale up our impact with a software. We built Agritecture Designer, the world's first farm planning software, where anywhere in the world you can estimate the CapEx or OpEx of a greenhouse or vertical farm, take online classes, conduct your market research, and connect with the best suppliers of equipment in the controlled environment agriculture sector. So as you can see, we've been busy over the last 10 years. We celebrated 10 years in October of last year. And today we're going to be talking about a very new milestone for Agritecture as we work on some new work related to artificial intelligence and hops. You heard it right, hops. So globally, we've been working around the world, so far 35 countries, and so we have pretty global experience. But today we're going to be talking about our first project in the Czech Republic, which is a very, very special place to my heart, because although I sound American, my mother is Czech. And I spent many years of my childhood and my life in the Czech Republic, and my parents to date still live there. So it's been really exciting to get that pin on this map in particular, and you're going to get even more excited as you hear about what we're specifically doing there. So as I mentioned, I'm from Agritecture. I'm the founder and CEO, started the company 10 years ago. And what I do for the company is do a lot of business development and thought leadership. And I manage an incredible team of global consultants all around the world. One of those consultants is David Caesar, who's calling in from Croatia. How are you doing, David?
I'm doing great. Thanks, Henry.
So David is our lead agronomist, and he's spending a year, I think, right, with your family in Croatia to sort of get a change of scenery.
That's correct. Yeah, we love it here.
Awesome, awesome. So you're going to hear from David in a moment. He's going to talk to us a little bit about the project that we're working on there. As he's our lead agronomist, he's been intimately involved with it. So if you've just joined, a reminder, you can use our Q&A chat and you can ask us questions. We're going to be answering questions after a couple of short presentations. And you can introduce yourself on the chat, who you are, where you're from. I'm in Dubai, David's in Croatia. And next up, we have Alma Cardenas, who works at AI for Earth and Ecosystems, Global Senior Project Manager at Microsoft. Alma, how are you doing today?
I am doing good. Hello, everyone. And I am based in Redmond, Washington in the USA.
Redmond, Washington. I mean, that is the mothership, right? I've heard there's maybe, 40,000 employees there at Microsoft offices. So it's kind of its own little city, right?
That's right.
That's awesome. And how's the weather going over there?
It's been raining and it's cold, but we like that there's rain so that we can have those water reservoirs filled up and prep for the summer. So
that's great. That's fantastic. Yeah, it's a beautiful part of the world and certainly very fresh with all of that water and nice air. So Alma, I'm going to turn it over to you. You're going to give our first presentation. You're going to tell us a little bit about AI for Earth and the Planetary Computer. So I'll let you share your screen. We'll give you a moment to do that.
So hello again, everyone. I am Alma Cardenas, and I am part of Microsoft Environmental Sustainability team. I have been leading the AI for Earth initiative, which is a 5-year program that aims to put technology to help us understand and manage our Earth's natural systems. We believe that technology has a very important role in helping us understand our Earth systems and allow us to monitor, model, and ultimately manage them. AI for Earth started back in July 2017. We are going to be 5 years this coming July. And you can think of us as an initiative that works at the intersection of environmental science and computer science. We really hope that we can get more and more environmental scientists to use, cloud computing, artificial intelligence. And we are really hoping that we can get a lot of computer scientists to spend more time on environmental science projects. So we are at that, intersection. And our program pillars focus on, democratizing access to technology. We want to bring access to technology through open source solutions as our planetary computer, and also through grants to get access, to the cloud. We also focus on innovation. We have a very small but mighty engineering team that is helping us build the planetary computer, which I will tell you a little bit more about it. And third pillar is the impact pillar, where we think that there are certain technologies that are ready today. So our goal is to accelerate time to impact through very targeted, grant investments. And one of the grant investments that brought me to work with Agritecture is our Signature Projects Initiative. And I will tell you more about that. In the 5 years of existence of our program of providing grants to access, the cloud computer and enabling projects that can use artificial intelligence for environmental sustainability, we realized that that is not enough. We realized back in 2019 that we needed to, bring the best that we have to offer, which is, technological innovation. And we invested and committed to build the planetary computer to provide the tools that are necessary for all of you to develop the solutions that are needed to face the challenges ahead, or the challenges that we have today. And in particular, when it comes to agriculture, we need to optimize resources. We really need to use every piece of land and make sure that we have the highest productivity possible with a minimal impact to our Earth systems. And that's where we think technology has a place. So the planetary computer you can think of as a geospatial analytics data platform that provides you the benefits of cloud computing, which is infinite compute, that it's scalable, and provides, data catalogs. We are leveraging public data sets, remote sensing, Earth observations that have an important role to provide the data that is needed to combine with, agriculture solutions that, can help anticipate drought, can help anticipate, extreme weather. Hopefully one day we will be able to do that, right? So that farmers can adapt their practice. In the impact category, I was telling you about the Signature Projects grant. And this is very exciting because we find a way to partner with our subsidiaries. We have a global footprint, and we also find an opportunity to partner with our customers. So it goes something like this. Is there a place where customer subsidiaries and AI for Earth can invest a little into developing solutions that could be implemented in less than a year, and therefore accelerate the time to impact? And it is, really quite an invigorating area of my work. This is what brings me a smile every day, is to be able to see it for real, a solution that is leveraging data to make better decisions that hopefully, will result in us achieving a little bit towards a sustainable future. And pointing cases are work for the Czech Republic with our customer Asahi, and partnering with Agritecture to help us, install a system that will allow hop farmers, adapt their practice so that they can address climate change and still, build a resilient practice for hops that will, provide income locally and maintain that industry. In terms of how technology for agriculture, the opportunities are vast. We have a lot of smart equipment out there. We can gather information, sensors that can be, installed on the soil that can allow us to understand what is happening on the soil. We have drones that can now, provide visibility visually, at an altitude to understand how come, there are different areas in the soil that even though it is the same lot, they behave differently. We can now, have precision farming practices where you optimize the use of water. For example, you only water where it's needed and when it's needed, or application of, fertilizer only in small areas where it's needed and when it's needed. So the opportunities are, vast, and we are just getting started. However, technology is just a small part of the equation, right? One of the complexities that we still need to deal with is connectivity to the farm. How do we provide broadband connectivity to the farm? How do we make these technologies affordable? How do we educate the folks on the ground to build the skills needed to manage such systems? So we need to have those strong collaborations with government, academia, technology to make this a reality. But the future or the present is on open agricultural platforms, data aggregation, and data sharing ecosystems, so that can provide, for an optimization of our land resources in a sustainable future. So a lot of work ahead, but I am so happy that we have organizations like Agritecture that can help us get there. Thank you.
Thank you so much, Alma. That was a very good introduction. It was great to see the map of the projects and hear a little bit more. I think there's going to be some questions, especially about the planetary computer and about AI for Earth. So if anybody has those questions, feel free to put them in the Q&A chat. I actually would like to ask you just a question for now as well. But could you, like, in the simplest terms, explain AI to us? Because I think it'd be good to sort of set the stage a little bit more for people that maybe aren't as familiar with artificial intelligence.
Artificial intelligence or machine learning came about on trying to see if we could make computers learn like we do. And actually, they started, creating algorithms that kind of behave like our neurons. So the challenge is, like, can we teach a computer to learn? And that is what machine learning is all about. So it requires a lot of data, and, computers are good at repeating the same thing. So, we have algorithms that can leverage data and teach a computer to recognize patterns that can help us, for example, forecast when we're going to have a drought. And we do this by, processing the data from many, many years before, many different places, so that the computer can recognize the patterns and be able to tell us, yes, there will be a drought based on this past data that I know it happened. I know it will happen again, or that's the goal in pretty lame terms.
Yeah, and similar to how we learn, right? As you mentioned, right? We sort of have past experience and we sort of gather that data and our little neurons connect and we make decisions. And that's what you're talking about, right? Is creating that in computer form so it can be really active and sort of this supercomputer that's going in the background and do things more efficiently, right? And I just wanted to talk about the planetary computer a little bit more because you emphasize that as well. And it's obviously a great project that you're specifically leading. But, talk about why it's important to have clean data. It's something you emphasize. It's already like prepared data, prepared big data for AI professionals to work on it. Can you tell us a little bit more about that, Alma? Why is that important that data is structured in a certain way? And how does that help optimize the process specifically?
As we create these algorithms to teach computers to identify patterns, right? They require data, but meaningful data, meaning we understand that the weather in the Czech Republic was 5 degrees Celsius in 1922 in this particular location. So those kind of characteristics, it's feature sets that allow us to identify the data cleanly so that we understand exactly what this means. And this data annotation, cleanliness or structure, needs to be there in order for algorithms to process that data. So garbage in, garbage out, right? So we need to have that data validated, right? Somebody or something out there made sure that this data comes from the Czech Republic in this particular GPS location, and it was indeed 5 degrees Celsius, because if that data is incorrect, right, our algorithms will not be able to, predict accurately, right? So it is of the most important, and this is where data scientists spend lots of their time, right? Data preparation and data readiness, probably, you guys tell me, but it's like what, like 80% of the job is making sure that your data is good. So if we could help a little bit reduce the time on that, you don't need to spend your time cleaning the data, making sure the annotations make sense. You can spend your time in the science, right? In predicting the drought for the farmer rather than making sure the data aligns, it's correctly annotated. So anything that we can do to help computer scientists or data scientists get data that is ready for process, that has a common standard, that it's annotated, it is going to make your lives a lot easier.
Thank you so much for that explanation, Alma. And it's really exciting to see the planetary computer has got some new features that were recently added just a couple of weeks ago with more data points and the Explorer tool where people can look through that data. And again, as you mentioned, really empowering the next generation of AI innovators for the world's greatest challenges around climate change on the planet. So thank you so much for that presentation. Just hang tight. If you have any questions for Alma about Microsoft's work, planetary computer AI, please put them in the chat. We'll be getting to them later. But next up, let's switch over to David Caesar, who's in Croatia. How are you doing, David?
I'm doing excellent. Thanks so much, Henry.
Yeah, glad you're here. Glad you're here. So before you get into your presentation, I'm just going to give a little bit of a transition from Microsoft into the project, okay? So, I don't know where to begin, but how it all really started. I like to network, I like to meet people, and I was introduced to Katarzyna Magna, who's the head of government affairs for Eastern Europe at Microsoft. And, she is a really big innovator and very creative. And she said, we're looking for challenges in this region related to climate change that we might be able to support. And so I just did some research and some work and prepared a bit of a draft. My mom always told me, when you're networking, focus on giving first and it'll always give back afterwards. So I tried to do this presentation. I looked at Eastern Europe and I was a little bit surprised, but Eastern Europe overall, Czech Republic, Poland, Slovakia in particular, are facing a lot of water issues. You may think of these places having a good amount of water, but they actually have certain water scarcity issues that are getting worse due to climate change. So I thought, well, let's do something related to that. And after many, many, many discussions, we ended up getting invited to propose a grant application for AI for Earth. And we really had the privilege of winning that and getting started. And so that grant application was related to working in the Czech Republic and helping hop farmers with Asahi, who is the really one of the largest global beverage companies. And I think about 50% of the beers in the Czech Republic come from Asahi. And the main prime beer, the first Pilsner ever brewed, Pilsner Urquell, is under their brand, is owned by them. So it was really like so exciting for me as a Czech person that's so familiar with that brand to get to work with Asahi and to start to interact with the farmers and think about how we can solve problems around this. So David, I'm going to pass it over to you now, and I'm going to just share the screen for the presentation.
Excellent. Thank you so much.
You can just say
Okay.
next whenever you want the next slide. Okay, David?
Next slide, please. So, hello, everyone. Just a little bit about myself. Right now, as Henry said, I'm coming to you from Croatia, but I've spent most of my life in California. I've worked in agriculture in California for more than 20 years, and I'm extremely excited to be able to talk to you today about this really exciting project we're working on. Next slide. So we're very fortunate to have two incredible partners for this project. One is Asahi, as Henry mentioned earlier. The other is the Hops Research Institute. And through those two amazing partners, they have connected us with 6 partner farms that we're working with on this project. Now, those 6 partner farms or pilot farms are located in Eastern Czech Republic near the border with Germany, and they produce approximately 2% of the world's hops production. So each of those 6 farms is quite large. They're about 100 to 200 hectares in size. And so if you're enjoying a Pilsner beer today, there's a good chance that some of the hops that went into that Pilsner beer came from one of the partner farms. So say thanks when you lift your next beer. Next slide, please. This is me in November when I was visiting some of the farms. So I was there at the end of November to install weather stations at the 6 farms. The farmers that we're working with are very enthusiastic about this project, but they're the ones that realize better than anyone the challenges that a changing climate can present. And they're definitely very eager for potential solutions. Next slide. So we want to understand a little bit what is the problem. And since I'm guessing that not everyone who's watching this webinar is a plant expert, I'll start with a human example. So as you've seen that top headline there about boys hitting puberty earlier than normal, and that has to do with lifestyle, with food, things like that. Sort of parallelly, plants are hitting puberty sooner than normal. So because of changes in climate, because of changes in water ability, this is actually causing this sort of acceleration of the plant stages. And according to a recent study that looked at the Saaz hops over the last 100 years in the Czech Republic, they estimate that the reproductive process is speeding up by about 0.15 days each year. So over a course of 100 years, it means the flowering process or the beginning of the reproductive process has moved up by about 2 weeks. Next slide, please. So hops develop in stages, and all plants develop in stages. And so this is a sort of a chart that illustrates the different stages of hops development. And so what was previously occurring in X days, right, now is occurring in X minus a question mark days. And that's really one of the main questions we're trying to figure out as part of this project. We're trying to understand when each of these stages begins and transitions to the next stage. We're pretty sure these concentrations of each of these stages is happening due to the increased warming, due to limited water, and do the stresses caused by both of those things. But that's where we're really going to learn during this project. Next slide, please. Now, how do we see the impacts, or what are the impacts that we see in the hops plants themselves? So as I said before, the first thing is we see compressed development stages. So the first stage, or one of the first stages of the hops plant, is a vegetative stage. So the plant grows, it grows vertically, it develops a lot of biomass, right? And this stage essentially prepares the plant for the next stage, which is the reproductive stage. But if this vegetative stage, this growth stage, occurs in a more compressed way, if it doesn't have the full time it needs to develop, then the plant isn't going to have enough biomass to support the reproductive capacity that it could have otherwise. Okay, so yeah, and what we see is yield reduction. So in 2015, the impact was an average yield of about 2.1 tons per hectare. And last year, which was a year with ample rain, ample moisture, the yield was 4 tons per hectare. So a very significant difference and a very, all too real impact for the hops farmers. Next slide, please. So we've outlined the problem. Now the question is, what are we going to be doing about it? So our solution has several portions. The first one is we're using equipment from one of our equipment providers by the name of Zeitgeist, a Canadian company. And what we're going to do is we're installing these cameras in the hop fields, and these cameras are taking pictures at a regular interval. And the goal of this is to identify exactly when each of these growth stages start, right? Start and end. So what we want to do, this is a tracking mechanism. We want to really track where each of these stages begins and ends. And this will be really valuable when we combine with the other data that we're collecting. Next slide, please. So in November, I said we installed weather stations. We installed weather stations and soil sensors, and those were provided by another project partner called Metos, based out of Austria. And the goal here is when we have the tracking information, or the information where we can observe the plants transitioning from one stage to another, right? When we overlay these environmental observations, we create really meaningful data about what's going on in each stage of the plant's life, right? We can see how heat may be accelerating the length of a stage, may be shortening it. And so this really gives, when we're able to sort of like look at these two sets of factors together, or these two sets of data, it really gives us valuable information about what's happening during each stage of the plant's life, and what are the factors that cause the plant to transition to the next stage. Next slide, please. The third part of our solution are sap flow and stem diameter sensors, which are coming from a partner called To Grow Earth, based out of Belgium. These sensors will be installed in the spring, probably in mid-April, after the plants have been pruned and begin to grow again. And what's going to be really valuable about this information is we'll be able to see when the conditions become too stressful because of excessive heat or limited soil moisture, which actually causes the plants to shut down. This information will help guide us in the future to know what conditions to avoid, if at all possible, and to guide good irrigation practices. Next slide. And then kind of the last part of our solution is to combine everything we're learning with other data sets. And these other data sets We'll get them from AI for Earth, we'll get them from the Planetary Computer. And this is where we can really create a project that has an impact not only for the 6 partner farms, but also for hop farmers across the entire region. For example, our goal here is to calibrate with specific data we're getting from the partner farms with the data sets from the Planetary Computer, and use this information to estimate what is happening at farms where we don't have sensors installed. Next slide. So as I said before, we're still in the initial year of this project, right? We just installed the first set of equipment in November. I'll be going again in early March to install the rest of the cameras, and then the sap flow and stem diameter sensors will be installed in the spring. So, and then the growing season will go through September. And so this is the first year we're really tracking data. But the next 2 years, years 2 and 3, are really critical to this project, because during those 2 years, we'll be able to test different management strategies at the farms to see how we can reduce plant stress, to see if there's ways where we can lengthen those development stages. The 6 trial areas at the partner farms display a wide variety of conditions relating to the age of the SAWS plants, the soil type, the irrigation methods. Some of the farms that we're working with have irrigation systems, others do not and rely just on rain. And this will allow us to create solutions that have an impact across as many farms as possible. Next slide, please. So just to review our process quickly, first step is to build our yield and alpha acid models by combining the historical data, the data we're collecting from the pilot farms, and data from the planetary computers. We'll do this using machine learning models, and this is being done by our partner Tenso AI out of Canada. Then, as I just said, we'll be running trials at the pilot farms to better understand what management techniques we can use to sort of like pull the appropriate levers for improving the outcomes for yield and alpha acid content. And then finally, part 3 is to expand the model to other farms in the region based on the data from the planetary computer. And as I said, our goal is to provide insight to as many farmers as possible without requiring the installation of sensors and technical equipment at these other farms. Next slide. So that's all I have in my presentation, and I'd be really happy to answer any questions later on during this webinar.
Great, thank you, David, for laying out the project, our project partners, the various technical components, and I'm going to ask you some questions as well, and then we'll open it up for a little bit more. But one of the questions from the audience that I think we have to answer really well is, what are hops? Okay, so I will try to answer that. But hops are essentially the little flowers, the cones that grow on the hop plants. And hop plants are planted in the ground. They typically grow 8 meters up, and then they're put in fields. And obviously, because they're so high, they need to be supported by various structures to make that work. Now, why do people grow hops? Because it's one of the key ingredients in producing beer. It actually has a special aroma that actually helps create the flavor and the bitterness in beer. So combined with barley, it's one of the key ingredients required for beer. And this particular variety of hops, called the SAWS variety, which all the farms that we are working with produce the SAWS variety, is the particular variety that Pilsner Urquell produces or uses for their beer in the original recipe that's only produced in Pilsen, the 2nd largest city in the Czech Republic, and frankly, the capital of beer in the world. So that is sort of a little bit of what hops are. But a little bit more about that, again, it cannot be understated how critical these hops are to the Czech tradition and to the Czech economy. What I think is really cool about this project is it's not just about the incredible need for farmers to handle volatility due to climate change, but it has other layers of the economic value of that crop. The Czech Republic is the 3rd or the 4th, depending on the year, exporter of hops globally. So this is a country of only $6.5 million that has is on the top, 5, top 3 list of an export product globally. So very, very critical to the economy. And then it has this traditional cultural aspect to it. If you go to the main town, Zatech, which is the town where all the hop fields are sort of around it, it's actually a UNESCO heritage site. So with this AI for Earth grant, it's not just about the agricultural elements of this. It's about the socioeconomic and tradition elements of this, which is why it's so important that the farmers get ahead of this and have more support that they need to produce the incredible world-renowned product. And just a little bit more about microclimates, right? David emphasized something that was very important, right? We're doing it with the 6 farms. We're trying to extrapolate that value. And Alma, you talked about this too, right? If we can figure something out somewhere, AI can allow us to apply it to other places. So these are what we call microclimates, right? This is most of the production of hops is in this particular area, which means that it's sort of a climate that has conditions that are a little bit vulnerable to different changes. So think about like champagne, right? Or different wines. The reason they have those flavors is because of the conditions to grow them. Those conditions are shifting due to climate change. And so farmers need more tools to understand that because they see volatility in yields and in quality. David, tell us a little bit more about like some of the first impressions you had when you worked with the farmers and visited them. I got to visit them too, but anything else that you noticed or observed when you were there?
Well, I would say like these farmers are really world leaders in hops production. These guys are, visiting the US regularly. They're going to conferences with hops producers in Washington. Washington is the main production area in the US. So these guys are sort of like world leaders in hops production. And so very impressed by their knowledge and the folks at the Hops Research Institute. These guys have been working with hops for decades, and they're the real experts. So, we're using their expertise as much as possible to help guide this project and make it a success for all involved.
Yeah, I definitely saw that enthusiasm. I was really impressed by their creativity, the things they've tried, just how upfront they've been. And it's been really great to work with them so far, and really quite innovative to see how enthusiastic they've been. So we've got some questions. So let's dive into some of them. I've got some of them over here. So let me pull them up. This one's for you, actually, Alma, if you're ready to go. This from Hadar is curious to learn more about how planetary computer layers various types of data from various sources to get more holistic insights and predictions. I mean, that's a pretty big question, but how does it sort of layer it? Maybe he's talking about putting one layer of rainfall, one layer of land. Can you find relationships there? What are the tools related to that?
We have on purpose built the planetary computer on open source and leveraging open source functions though. So we have adopted the open source standard for geospatial known as STACK. So this standardization and working with GeoTIFF cloud data, optimized data sets will make that layer, easier to implement. But the layering will be specifically for the solution that you're trying to address, right? So, David, I am curious to see what data selection you guys are using for this particular solution. You're bringing weather information, probably. There's vegetation indexes, there's all kinds of things that you could bring in. I don't know what you guys are finding useful.
We're looking at some of the vegetation shifts as well as rainfall. Those are some of the specific ones. I think there's 2 other ones that we're utilizing. Raman in the chat can share it too. I know he's watching from Tenso AI, but I think those are the main ones that we've been investigating so far. David, anything to add there?
Yeah, we want to get as much information. Any data sets relating to soil moisture are critical for this. And also any data sets where we can leverage specific environmental conditions data from these locations, the different hop fields, because of
Right,
course
but for
we're
the
going to
planetary
be.
computer, we're looking at like the rainfall, like from the satellite data of planetary computer, we're looking for like vegetation changes, land changes, rainfall, just so people understand what to expect from planetary computer. It's you know, a lot of them are satellite-based data sets for different regions and globally that are cleaned up. And then you can layer them against some of the things that David mentioned, right? Which is what's happening on the farm specifically. Sorry, David, to cut you off. Continue.
Right.
No,
Yeah,
but I was going to say there's just a lot of holes in the actual data we have from the farms that we're working with. So our goal is that, you know, through the planetary computer, we might be able to fill in some of the missing information and add additional layers to the data sets that we're working with. So.
Okay, great.
but just to go back to the question, what makes that layering simple or not simple? There's nothing simple of this though, but is, you know, the adoption of, you know, standards, open standards, right? So it's like all of us agreeing to use this common standard that we have implemented on the Earth observations images though. So we hope that using that stack open standard will make this layering go easier.
Got it. That's helpful. So a question for you, David, from the audience was about the yield in 2021 that was higher than 2015. And the question, I think we sort of talked about a little bit, but is it the year-to-year variation that's one of the main concerns? Can you talk a little bit more about what the challenge is related to different yields and also maybe acid content per year?
So when we think about the challenges regarding yield, you know, it's two things. It's really about the economic livelihood of these farmers, right? Are they going to be able to have viable businesses, right? Because when the year 2015 versus 2021, right? The farmers have to invest the same amount of resources for that acreage, right? So it costs them essentially the same amount of money, but they don't know what the yield's going to be, right? So what we're trying to help them do and is, you know, not only to understand about crop management, but we think using AI and we think creating these algorithms will help the farmers get a better understanding of the labor needs of their farm, right? So if they know, if we can use these predictive information, if we can use, we can help the farmers say, okay, we know next week or we know in 3 weeks that there's going to be a really dry spell, you know, we're going to need to irrigate appropriately, or we know that, you know, this year's growing season has been compacted. We think the harvest is really going to come about a week earlier this year, right? We need to begin to align up labor for that specific period. So it's not, this project is not only about understanding how the plants will behave. We also think there's going to be a lot of value provided to the farmers in understanding how to more efficiently manage their fields. So.
Yeah, it's really about, you know, helping them to be more efficient and be more aware of what's happening. I mean, again, these are large farms, right? So they have a lot of things to watch out for, as David mentioned. And this goes into one of the other questions which was brought up, which is, are the farmers using any regenerative methods? Are they using no-till methods? Are they using other strategies? And I think I'll sort of attempt to answer that question. Farmers in general are under extreme amounts of pressure. Their margins are very tight, and issues around demand changes, supply chain, commoditization of their crops, as well as pressures in the case of the EU to reduce certain inputs that they need or they've typically used, have made their job really difficult. So what we're trying to do is we're trying to help them understand where they can focus their energy for certain interventions. And there certainly are other things that they could do to optimize their farm from a sustainability or productivity perspective. But without a lot of data on how to do that and the results of that, it's very difficult to take those risks and make those decisions. And that can range everything from investing in a well to different irrigation strategies to what we call cover cropping in between the rows of the plants that can help to retain more soil moisture, to using different fertilizers or avoiding different pesticides. So all those things, you know, a farmer really is they're willing to take risks, but they want to have data and more actionability and evidence that's going to work before they take those risks. Anything to add to that, David, on some of the, you know, sustainability practices or maybe some of the perceptions of farmers and the challenges they have?
Yeah, I mean, all the farmers that when we visited in November, all the farmers were manuring their fields. So they do use, you know, organic matter and manure as nutrient sources for their fields. But you know, they do plow their fields, or they do some limited plowing to reduce weed pressure. And, you know, the farmers have a lot of pressures around things like downy mildew, which is a problem that can come with too much biomass and too much moisture in the field. So they have to be very cautious, because if they get an outbreak of downy mildew at the wrong time, it can really threaten their entire crop. So yeah, the farmers are very aware of different practices. They're very aware of regenerative techniques, and you know, I think they try and include those that they feel are practical in their cultivation strategies.
Alma, let's turn over to you. A question from Stephen over here was about Microsoft AI for Earth and does it work with Azure? Maybe you can help the audience understand a little bit with AI for Earth, planetary computer, you know, and the sort of wide ecosystem of solutions that Microsoft provides for agriculture. I can also add to that and talk about what we're doing, but any thoughts there?
Azure is Microsoft's cloud. That's where we provide, you know, all the different services that could be used for all industries. AI for Earth is an initiative that was to bring those Azure services to help the sustainability challenges with, you know, climate change, water, agriculture, and biodiversity. This is specific applications of technology in environmental science. And out of that work, we realized that we needed to invest even more in building the planetary computer, which you can think of a data platform that allows the manipulation of Earth observations, right, for sustainability. And it is bringing those, you know, data sets to the Azure cloud with the tools and based on open standards that will make environmental scientists find the data they need. So David can go easily and use the data explorer, which is rendered as a map, and say, what do we have in Czechoslovakia for this, right? What data sets are available in this area, in this time frame, and in this geography. Searching those data sets can be extremely hairy. It's those layers of images and images of satellite, you know, different, taking photographs of Earth in different angles. There's a lot of math that needs to occur so that you can do that alignment of those data sets. So we hope that this open standard data sets can make that work easier. I don't know, Henry, did I answer the question?
Yeah, you did. And just to say, we're using Azure. We have support from Microsoft team, both internationally and locally. We're also using FarmBeats, which is an existing solution for farmers. It relates to a lot of the satellite data. So we're really trying to bring this in, right? Because we're trying to apply a lot of the Microsoft suite of solutions as well, because Asahi is a customer of Microsoft, and there's a lot of value to the farmers in utilizing those. And then we're doing our own little sort of customized, unique things along the way. Of course, with our partners, Tenso AI, they're providing a lot of value in this. David, I want to get to you on the farmers a little bit, right? This is a good question. Sergio's asking, sometimes producers are reluctant to share information. How did you break down this barrier and make it happen? I'll begin, and then you can sort of get going. I think, look, it really begins with being humbled by what the farmers are doing and listening to them. So we really began just by visiting the farms. I went on the first trip with Ivan from Asahi, and we got to meet with the farmers and just sort of look through their fields and talk about what they're doing. Where are you irrigating? Where are you not? What are the challenges you're facing? talk about your yield data, but not like pressing too much to just get data, just get to know them a little bit and understand what they're experiencing. For me, it was good. It pushed me to challenge myself and speak Czech and learn a little bit of agricultural Czech. And that's another way to sort of break down barriers a little bit, is find common ground, right? Find the middle ground between you and them. I'm obviously come from the city, so I'm always humbled when I visit farmers, especially field farmers. So then after that, it became about visiting again and giving them some time to think about which of your sites that we looked at would you be interested in think about for a pilot. Another aspect of getting information, working with farmers that's important, is to work with their partners, right? So Asahi is the group that knows the farmers, and they buy the product and they process that into this incredible beer. But also there's other groups like the Hop Research Institute or other consultants that have worked with the farmers before on IoT, like the Smart Hops project that has also been existing under the advisement and guidance and support of Asahi prior to us. So it's about really looking at that ecosystem and finding how you can connect. And so I think I did the first 2 visits, and then David, you got to go there. What's it like working with the farmers and getting information? How big of a challenge has that been?
So I think, 2 things are really important. One is asking questions, right? The last thing farmers want is for someone to come in and tell them what that person thinks they need to do, right? Farmers have been doing things for years in a certain way, and they're usually very resistant to change. So, really learning from them is the critical first step. So whenever I interact with farmers, just asking questions, trying to learn from them is critical. The second thing is, we were doing these equipment installations. I was digging holes, I was getting dirty, and I think farmers really respect when they see someone who's actually doing work, not someone who's just standing there with a clipboard and, sort of like managing the situation. So, kind of sharing that experience with the farmers of working together and getting dirty builds a lot of confidence as well.
Yeah, I agree. And that's why it's great to have someone like you, David, that has agricultural experience on the Agritecture team, so that we can, you really have different kinds of field experience and various parts of that, which is why you're a lead agronomist. So
Right.
Let's give you each one more question. Alma, what is your vision for the future of agriculture and artificial intelligence?
The foundation, we really think that you cannot manage what you don't understand, and you really don't understand what you are not measuring. So I think that in the areas of agriculture, we are, as humans, we are competing for more and more land for agriculture. Population is increasing. We need to address, feeding a growing population. And we need to do that without continuing to trash the planet with it, right? So we need to optimize every piece of land to make sure that we are obtaining, the max, products on that piece of land. And how do we do that? We think that data and measurement and computer science as a tool can help us, get to a better decision-making process, right? Like, we hope that David, after 2 years or 3 years of trying to install this, measurement equipment, aggregating the data, can get to a farmer understanding why the crops are being reduced. I don't know the exact term, David, that you mentioned, right? But why are crops, not growing how we know they used to grow for years and years and years? So there needs to be an adaptation of the practice, right? And we need to do that through data. So the future is hopefully that we leverage technology to help us become smarter when we have to make decisions on, on the field of agriculture. It is not simple. Perhaps I am painting it quite rosy. It is quite hairy, actually, and it's a intersection of field studies, right? We need experts like David, and we need experts in computer science that can work together. So technology is there, collaboration needs to be there to get us to better decision making for sustainable planet.
Thank you so much, Alma. We definitely share that vision, and it's been a real privilege to work with you and the whole Microsoft team on this grant, and we hope to continue to do so. David, really quickly, what's your goal and your vision for the project? What is success for you? Really quick.
Success for me, farmers have a better understanding of what's going on in their fields and have better outcomes, right? We're really focused on doing whatever we can to reduce the plant stress, have better outcomes relating to yield and alpha acid. And yeah, and to implement these solutions in a way that can also, you know, save time, be efficient for the farmers, save labor. You know, that's really critical for this project to be success.
Fantastic. I couldn't agree more. Well, thank you to all of you for tuning in for this AI for Earth, AI for Hops webinar with Alma Cardenas and David Caesar and Henry Gordon-Smith. If you want to learn more about Microsoft Planetary Computer, just Google Planetary Computer and take a look at all of those projects. You can also look at AI for Earth case studies, really inspiring work all around the world. If you want to learn more about Agritecture, you can go to agritecture.com. If you want to learn more about this project, including watching videos and subscribing to the newsletter, getting updates, just go to 4hops.com. And you can learn all about the project. We're installing the rest of the equipment soon and going through the first growing season with 6 farms empowered by IoT and Microsoft AI. So we're really, really excited about all of that. I want to send a special thank you to Microsoft, to Asahi, our local partners, to the Hops Research Institute, to the 6 farmers that are doing incredible work to work with us and being pioneers in the sector. Of course, to Tenso AI, also to Zeitdice, also to Pestle, also to Grow to Earth. And it's been really such a pleasure to work with all these partners. You know, this team is really a team of about 35 different people across many continents. And it's really about partnership that we can work together to solve these great, great challenges. And thank you to all of you for tuning in and spending some time to invest in knowledge with us. Have a great day. Take care.
Thank you, Henry. Thank you, David. The privilege is ours.
Thanks so
Thanks,
much,
everyone. Take care.
Bye.